Some parts of the UK are on day 11 of this third heatwave of the year. We had the early heatwave in May, followed by the humid heatwave in June, and now this particularly long-running heatwave in July. But what are the impacts of these three heatwaves? In this week's Met Office Deep Dive, I'm going to be exploring the various consequences as a result of having so many bouts of hot weather so far this year. Impacts on our health, impacts on vegetation, and impacts on the seas surrounding the UK. And how long will this current heatwave last? Is there an end in sight? Is there any rain in the forecast? Welcome along to the Met Office Deep Dive. If you enjoy these in-depth explanations of the UK's weather, please do hit subscribe on our YouTube channel and tell your friends about it, because the more support we get, the more of these we can do. Now, I mentioned this is the third heat wave of the year so far, and this is beautifully illustrated by this graphic showing the maximum temperatures averaged across the UK from the 1st of April up until this point, mid-July. So, yeah, June, first half of July, we're now just about heading towards the halfway point of the summer. So I thought it would be a great opportunity to do a half-time analysis. And what a summer stroke late spring it has been in the UK. The three heat waves really stand out on this as these three peaks. So there's the late May one, above 25 degrees Celsius. Remember, these are maximum temperatures averaged across the whole of the UK. Followed by the late June heat wave, again a longer and higher spike there, and now this early to mid-July heat wave, once more above 25 degree average and lasting for considerably longer than the last two, although not with such elevated temperatures this time, and we're likely to see a gradual cooling trend during the rest of this week. More on that in a moment. But yeah, quite an outstanding summer and spring so far, but not for everyone, of course. This map shows the maximum temperature for almost the first half of summer, averaged across the UK, and we've got England and Wales, a considerable part of the southern half to two-thirds of the UK, above 1.5 or 2 degrees Celsius, but Western Scotland, a little cooler than average as far as maximum temperatures are concerned. I haven't got the rainfall map in front of me, but Western Scotland has also been the wettest place, with significantly drier than average areas across eastern England. This is the average rainfall compared with what we'd expect at this point for the summer so far. And actually, you can see that this is what you'd normally expect, or this is the average, I should say, the black line running through the middle. As the rain adds up through the summer, the average by the end of the summer is 250 millimetres across the whole of the UK, where the line here is above the black line. We've got this blue shading. That means that it's been wetter than average for a good part of June up to the first week or so of July. We were running at above average rainfall across the UK, obviously with those regional differences. But now that running total of rainfall has dropped below the black line, so now below average rainfall up to this point, only slightly though. But again, very clear regional differences from the northwest of the UK to the southeast. But yeah, it was a wet start to June for many parts of the country, which makes the current hot spell and the late June hot spell so remarkable that temperatures managed to get so high, despite it being, up to that point, a wet summer so far. This, though, is one of the standout statistics from the summer. What I've got here is instances of equal than or greater than 30 Celsius, 32 Celsius. Let's go back onto that and try not to touch it this time. 30 Celsius, 32, 34, 35, 36, etc., all the way up to 40 Celsius. And which year had the most number of days equal to or greater than these temperatures? So starting at 30 Celsius, 1995 had the most number of days at or above 30 Celsius. You might remember it. It was the driest summer on record, even drier than the second driest summer on record, which was 1976. So no surprise that we saw the most number of days at or above 30 Celsius. 34 days in total that summer. 2026 so far, up to the halfway point, of course, we're at 24 days. I say summer, but this is a count for the whole year. So, some of these days occurred in spring, obviously. 32 Celsius, again, 1995, the standout year. 19 days that year at or above 32 Celsius. This year so far, 17 days. So another 3 days, 2026 will be the day with the most number of 32 Celsius days. Skipping those middle numbers for now, and you get up to the really extreme temperatures, of which we've only seen a handful, 37, 38, 39, 40, and for 38, 39, well, for all of these numbers really, 2022 was a standout year because of course they happen so infrequently. 2022 we saw 2 days at 37 and 38 and 1 day of course at 39, 40. So 2022, the remarkable year for those. But these middle numbers, these are the important numbers for this year because this year already we've seen the most number of days at or above 34 Celsius, 35 Celsius and at 36 Celsius tying with 2003 and 1990, so 963. And it's those mid-30s numbers that are important when it comes to impacts in the UK, because impacts on infrastructure and people's health, well, they can vary considerably depending on a number of factors, but as a very rough rule of thumb, you'd typically be looking at the mid-30s temperatures for impacts to start to escalate in terms of roads melting, railways buckling, and widespread, not just localised, but widespread population impacts. So those mid-30s numbers are important, and this year has seen a remarkable number of those mid-30s. But temperature, of course, we kept emphasising this in late June, is only one aspect of things, because I want to go back to that incredible heat wave at the end of June. It wasn't just about the air temperature, it was about the humidity. And this map here shows the wet bulb temperature from the 25th of June, the peak of the late June heat wave. This is the wet bulb temperature. We talked a bit about this at the time, but I'll just describe once again what the wet bulb temperature is. Wet bulb temperature is measured in a similar way to the air temperature, but with an extra component to the thermometer. The thermometer has a damp cloth attached, and that damp cloth then will evaporate water into the air surrounding the thermometer. And as that water evaporates, the air surrounding it cools. When water evaporates into the atmosphere, the air cools down, a bit like when we step out the shower covered in water, that water is evaporating from our skin, we feel cooler, that's why we sweat. So, wet bulb temperature is a measure of how much the air is cooling as a result of evaporation. Now, the more water vapour that is already in the air, then the slower that evaporation will happen and the less cooling you get. So, this is a really good indication of how humid it is, essentially, and, more importantly, the impact on our own bodies, because as opposed to thermometers, we cool down by sweating. And the higher the wet bulb temperature, the less efficient that sweating is. So that's why the wet bulb temperature is so important, and it was crucial during that late June heat wave. We saw temperatures widely into the mid-30s and in one or two spots 36, 37 Celsius. But what was more important is that we saw wet bulb temperatures into the low to mid-20s. We saw observed values of 25, 26 Celsius, and that's what this map is showing. This is actually not the observed values, but the forecast values for the day, and I've coloured it up with 5-degree increments here and given them little descriptions based roughly on some science about the upper limit and some dangerous temperature values. So the upper limit for the wet bulb temperature for human survival, according to scientific research, is 35 Celsius. And that's because our skin temperature needs to be kept at around 34 Celsius, 35 Celsius. And if you're not able to cool down below 35 Celsius by sweating, then your body can't cool down. So this is the upper limit, and it's exceedingly rare to get wet bulb temperatures above 35 Celsius. So that's the upper limit. Then above 30 Celsius, still relatively dangerous levels of wet bulb temperature, and not that common across the world, but they have been observed in many places like India, Pakistan, the Persian Gulf states. They sometimes get into those values as well. 25 degrees or above, I put there as oppressive, and this map shows that we saw this swathe of mid-20s, 25, 26 Celsius across central southern England into southeast Wales on that day, the peak of the heat wave. So those particularly oppressive values, really quite uncommon for the UK. That's what we saw during that hot spell, extending into the near continent as well, parts of France, as well as the Netherlands and Belgium. But look how it compares with the rest of Europe. Not as high, even in some of the hotter countries across Spain and Italy and Greece, because humidity levels weren't as high, despite higher temperatures at the time. So yeah, that value, the wet bulb temperature on that day, the peak of the heat, widely elsewhere, 20 to 25 Celsius across Northern Ireland, Southern Scotland, England and Wales, a little bit more comfortable towards coastal parts and the far north and northeast. And that was a key reason why that heat wave was so dangerous. And you might have seen in the news a paper that came out, some research that came out this week that was researched, led by the Met Office, Imperial College in London, as well as, just get it right here, Met Office, Imperial College London, London School of Hygiene and Tropical Medicine. Now, they used historical mortality records and peer-reviewed methods to model fatalities during both the May heatwave and the June heatwave. And what they found was that 550 people are estimated to have died during the May heatwave due to heat-related causes, 2,200 during the June heatwave, again due to heat-related causes. So these are estimates based on solid research, and of course those two heat waves were boosted by climate change. It's reckoned that maximum temperatures were 3 to 4 degrees higher as a result of climate change than they would have been with the same weather patterns without global warming. And so 42% of those heat wave related deaths were reckoned to be attributable to the additional heat caused by human-caused climate change. So really important research that came out and shows the impacts of these hot spells. Now, it's lovely in this country when we get some warm weather in the summer and we can go out and enjoy the sunshine. Temperatures get into the high 20s, perhaps low 30s. Those are the kinds of temperatures, as we saw often in 1995, 1976 and so on. Thoroughly enjoyable warm weather, although still with impacts, of course, due to lack of rainfall and so on. But these heat waves, where we're getting more regularly temperatures into the mid-30s, can be much more impactful in terms of population health and other impacts. Now, one other impact, of course, is that despite the wet start to summer and a considerably wetter than average for many winter, we've seen a remarkable drying out of the ground during recent weeks. So these two maps, these two satellite images, are separated by around 7 weeks. This is late May, and then you can see the colour difference by the start of July. It's not just about the lack of rainfall, which of course we haven't seen much of in July so far, but it's about the heat. The higher the temperatures are, the more evaporation you get. So one of the things that can happen with these modern day heat waves is that you get the ground drying out much more quickly, despite seeing actually quite considerable rain in some places during the summer, as opposed to those much drier summers that we saw back in 1995 and 76, where you had barely any rain for weeks and weeks and months. These heat waves, you can get wet periods like we did at the start of June, but then very high temperatures which rapidly dry out the ground. So these remarkably different maps there emerging, and what you could just about see there across Derbyshire and extending into northwest England. And this plume of smoke is currently visible. Manchester Airport, this is the observation from Manchester Airport. This is the METAR. This is what airports report. This is how they report their weather in the code here. And you might be able to make out it's got 5,000, that's the visibility, 5,000 metres. And then this FU, that's smoke. That's what the code is in a METAR for smoke. Because METARs, you might not know this, METARs use a combination of English words and French words. So sometimes the initials for weather are to do with the English word. So for example, FG would be fog. That's the English word, but FU is fumée for smoke. So that's the French word. But yeah, doesn't happen that often. Manchester Airport reporting smoke and a reduction of visibility as a result. And this map here, it's only looking at England and Wales, by the way. It's not covering Scotland and Northern Ireland. But for England and Wales, it shows the fire severity index, and it shows it's either high or very high across England and Wales. What does this mean? It's not the risk of wildfires, but it is how severe a wildfire would be based on antecedent conditions if one were to develop. Now, although a lot of wildfires are started by people leaving barbecues around and sometimes by, sadly, arson as well, this shows that the antecedent conditions can then really make it worse. It can fuel those fires once they start, and this takes into account rainfall, droughts, the state of ground, temperatures, wind speed, really important, as well as, so it's wind, temperature, humidity, rainfall and drought. I was speaking to a Canadian meteorologist about a month ago for a separate video that we're working on, and in Canada they use a 30-30-30 estimate as a rule of thumb for looking at wildfires, and 30 degrees Celsius, 30 km/h winds or above, and 30% relative humidity or below. Those are the three. If they happen together, then it's reckoned that wildfires are a greater concern. So at the moment, we've got relatively high temperatures. We've got high 20s, low 30s across many parts of England and Wales. We've got very dry air, and importantly, the last few days we've had this strong wind blowing across the south and the east in particular. So the antecedent conditions are raised in terms of wildfire risk. It's not just the UK, of course. There has been some really tragic reports in the news in the last few nights about Spanish wildfires, and Spain has been particularly badly affected so far this year. It is the country in the European Union that has lost the most surface area due to forest fires during the first half of 2026. According to Copernicus, that's the European agency, fire has ravaged 50,000 hectares, and that's nearly 40% of the surface area burned in the EU so far has been in Spain. And we've seen those tragic reports in the news during recent days. This is a satellite image of the wildfire that's currently burning in France to the south of Paris, Fontainebleau forest. You can see the smoke emanating from this area. It's active fire here, and then smoke going westwards, and this burn scar, this dark mark on the ground. So a really significant fire there in France. Of course, France has had a truly exceptional summer so far, regularly recording temperatures in the mid to high 30s and in some places the low 40s for days on end. It's very dry, very hot, and right now it's windy as well. So France, Spain, like the UK, wildfires are a real concern at the moment. One final serious impact of the heatwave, of course, is that we now have a marine heatwave across the UK. And in fact, on July the 10th, the heatwave category reached extreme, with some of these areas around the south coast of England reaching 3s and 4s. And that indicates temperatures 4 to 5 degrees above average. So surrounding UK waters on the 10th of July, we had well above average sea surface temperatures and extreme, well, strong to severe, and in some places extreme marine heatwave conditions. That's come down a little bit. This is 2 days later. Of course, we've had a bit more of a breeze to stir things up, so it's mostly strong to severe, but the elevated sea surface temperatures are moving north, expected to cover much more widely the whole of the UK over the next week or so, with these marine heatwave categories varying in number from 2 to 3 in the south up to 1 to 2 further north across the UK. And you can see here how much the sea surface temperatures are raised surrounding the UK waters, above average virtually everywhere, but well above average around some of these western, southern and eastern coasts of England, as well as Wales. Not just the UK, of course. I talked about France having an exceptional summer. This is the Bay of Biscay. Sea surface temperature this year so far, and 2026 is this line, and it's already above the previous record for the Bay of Biscay, which was set in August 2003. That's this line here. So it's already above that line. You'd expect temperatures in the seas in Northern Europe to peak in August and September. And that's what happened in August 2003. This year, we're already above that previous record. So truly extraordinary sea surface temperatures in the Bay of Biscay. We're talking about 24, 25 degrees or so. And this is the global perspective. Now, UK waters, Bay of Biscay, Mediterranean really stand out, these dark reds, 4 to 5, and some parts of the Mediterranean 6 or 7 degrees above average right now. And a lot of red on this map. Not entirely red, there are some blue areas, of course. The most notable one being across the mid-Atlantic here, this blue blob that does make an appearance quite frequently, and that's an entirely separate conversation for another deep dive, I think. Another thing that stands out, of course, is this El Nino, very strong El Nino developing, and there's the signature across the Pacific of the El Nino, which is likely to, through this year, increasingly cause all sorts of disruptive weather patterns across the globe. Again, another topic for another deep dive. But one really important consequence of the marine heatwave, of course, for the UK is its effect on marine wildlife, algal blooms, as well as disruption to ecosystems and habitats, and mass mortality of fish populations, and the introduction of new species, octopus, more jellyfish, and so on. So really important for ecosystems surrounding the UK. You have to have temperatures around the coast that much above average. And it may well increasingly influence our own weather patterns. Now, those kinds of anomalies can reduce quite quickly if you get a windy spell. But if those anomalies remain, then you can see enhanced temperatures by night. That's one consequence, so higher nighttime temperatures because the land doesn't cool off so quickly. Another one is that if we get future heat waves, then those future heat waves are already boosted by the warm seas surrounding the UK. Another one, of course, is more evaporation, and as we get later into the summer, if we get unsettled weather, if we get rain, you get more rain as a consequence. So when it rains harder, and there's a greater risk of flooding then, not just through the rest of the summer, but into the autumn and winter if those anomalies remain. So many reasons why these sea surface temperatures around the UK and in the wider seas and oceans around the world are so important. Finally, how's it looking for the rest of this week? How long will the heat wave last? I want to go back to this map, which showed the wet bulb temperature and how humid it was, how oppressive it was across much of the UK, away from central and northern Scotland on the peak of the June heat wave. Well, you've probably noticed it's not quite as oppressive right now. It's still humid, so still we're seeing temperatures, wet bulb temperatures in the high teens, but it's not as humid. You can see that difference. Let's just switch it back. That's the late June heat wave. This is currently across the UK. And if I just skip forward over the next few days, what you'll notice is that something a little fresher is coming in increasingly from the east. So these more comfortable colours are coming in from the east. And temperatures on a whole are starting to reduce. So at the moment, we've got high pressure over the UK. We've got this fairly brisk easterly wind. That easterly wind is easing, but at the same time, high pressure by the end of the week is drifting to the northwest, and that's going to allow something a little fresher to recirculate around the high pressure. Still above average temperatures for many, but by the time we get to Sunday, those temperature anomalies are reducing. And so this is what the maps look like in terms of how far temperatures are above average, widely well above average over the next few days. By the time we get to Friday, we've got these blues coming into the northeast of Scotland, eastern England and so on. And if we move on a little bit, you can see something a lot fresher coming into the whole of the UK by Saturday and into Sunday. So things are gradually cooling off for the rest of the week. It's not going to be cold, neither is it going to be unsettled, but the high pressure by the weekend is drifting into a position to allow something less hot to circulate around it. So we're talking by Saturday and Sunday temperatures in the mid to high 20s rather than the low 30s, the highest temperatures for Wales and the southwest, and lower temperatures towards the east and the north. But through next week, that high pressure is staying close by. So if it is rain you're after, there is very little sign of it for the next 7 to 10 days, with high pressure continuing to dominate. One exception, of course, there are some thunderstorms expected to come up from the south and southwest over the next few days. That's covered in our daily national weather videos, which you can find on our YouTube channel, and the longer term outlook and whether or not we're going to see any substantial and usable rain in the near future, that will be covered in tomorrow's 10-day trend. But for now, that's all from me. I hope you enjoyed this week's deep dive. I know a little bit depressing at times, but hopefully useful information. And, you know, that's what these are there for, to give you this in-depth look at the UK's weather and, of course, its consequences. Thank you for joining me. That's all for now. Bye-bye.